Hello everyone and welcome to today's Energy Storage News webinar with PowerUp and Socomec on the role of analytics in acute problem solving for battery storage assets. My name is Andy Colthorpe. I'm the editor of Energy Storage News and Deputy Editor-in-Chief for Publishing at Solar Media. There are always exciting technology trends to follow in this industry, of course. And for the past year or so, a lot of that excitement has been focused on things like increasing battery cell sizes and energy density, in other words, on hardware. While that excitement is justified, on another, perhaps deeper level, the industry is becoming equally enthusiastic about progress being made in the software space. Whether operating behind the meter at an industrial or commercial site or front of the meter at a utility scale project, battery storage hardware is only as smart as the software stack applied to it from the very beginning to the very end of the project lifecycle. If you've been reading Energy Storage News for a while and watched some of our webinars, you will be aware of the growing industry awareness of the capabilities that data analytics offer, enabling a greater visibility into the entire system from the cell level up, and ultimately giving better control of how these systems operate, which wasn't previously available. Today's webinar provides an opportunity to take a deep dive into the troubleshooting that data analytics from specialists like PowerUp can offer to energy storage solutions providers such as Socomec. And renowned European electrical equipment engineering and manufacturing group Socomec acquired PowerUp earlier this year. And I'm sure both companies will give you their reasons why this acquisition creates competitive advantages for each. But for our webinar today, this partnership enables us to hear the story of applied data analytics from both the end users and providers' perspectives. Socomec Energy Storage Solutions Specialist Elodie Hestin will discuss how data analytics enabled her team to grasp hold of otherwise very challenging performance issues, such as cell imbalances, state of charge accuracy, and state of charge calibration, offering visibility into the battery's operation in multiple regions and across a range of different applications. And then at the same time, PowerUp's Chief Revenue Officer, Philippe de la Forte, will be able to talk us through the details of how the analytics solution was able to step in, about the principles behind the analytics design and development, and much more. An audience Q&A session will follow Elodie and Philippe's joint presentation. So please submit your questions for the speakers in the questions tab you can see on the right-hand side of your screen. We won't be able to tackle all of them in the time we have today, but please rest assured, PowerUp and Socomec will be happy to follow up and respond in full and continue those discussions offline. And finally, from me, this session is being recorded and will be available in a few working days on the on-demand webinars section of the ESN website, along with the presentation slides. And so with that, and without further ado, it's my great pleasure to hand you over to our first speaker for today, which I believe is you, Philippe. Over to you.
Thank you very much, Andy. Good evening to you. Good morning, good afternoon, good evening to the audience. And good afternoon, Elodie. Very pleased to be here today with all of you. I'm Philippe de la Fortelle, Chief Revenue Officer of PowerUp, leading sales and marketing at PowerUp since end 2022. And I have a background in software sales and network analytics. With that, Elodie, do you want to introduce yourself?
Yes, thank you, Philippe. Hello, everybody. I hope you will all have a nice moment with us. So I am Elodie Hestin. I'm working at Socomec since 2008, and I'm especially working in the ESS field since 2017. As of today, I am acting as ESS marketing manager on a worldwide perimeter, though the main focus is more EMEA and North America. You can continue, Philippe.
Thank you very much for being with us today, Elodie. And thanks, Andy, for introducing our agenda today. So we'll start quickly by introducing PowerUp and Socomec companies, but then we'll head straight to today's key topic. And the central core of this discussion will cover the true value of battery analytics in terms of performance and safety. We will be using real use cases and common anomalies across a wide-ranging number of battery assets, be it small ones, medium ones, or very large ones. Most importantly, we will explain how analytics help identify these anomalies early and resolve them quickly. Quick word about PowerUp. So we are a battery analytics company created in 2017 as a spin-off of the CEA, which is a national French research institute specializing in renewable energy systems. And PowerUp has a team of electrochemistry and data science PhDs, all focused on enhancing battery safety and performance for our customers. Those customers are typically owners and battery asset operators, but also integrators. That's what makes this session today a bit unique. There are not so many battery analytics vendors working tightly with integrators, and that's actually the case here. As mentioned by Andy already, so PowerUp was acquired late 2024 by the family-owned Socomec group. Socomec is therefore both a shareholder and a customer, and therefore ideally placed to illustrate the value of our battery analytics solutions. And that's why we're really happy to have Elodie with us today. And with that, I'll leave it to you, Elodie, to introduce Socomec.
Yeah, thank you. So as Philippe just mentioned, we are a family-owned company. So we are 100 plus years old family-owned company, and our headquarters is based in France. But we are present globally over the world with our 30 subsidiaries and 12 production sites. Our 4,400 employees really focus on delivering solutions for availability, control, and safety of low voltage electrical networks. Our four main areas of expertise then are switchgear and electrical protection, so meaning we are delivering fuses, switches, transfer switches. Then power monitoring, so with monitoring devices, metering devices. Power conversion, mainly with UPSs, and energy storage systems, where we are, as Philippe said, a system integrator. So we have our own converters, and we integrate them with batteries from the main battery players. So at the moment, using CATL batteries. And it's important to mention that none of these products nor systems could work really efficiently without an associated offer of services, both human and digital. And today, we are going to give you more details about one of these digital services that can be provided thanks to the expertise of PowerUp. And Philippe is going to introduce in more details the topic.
Indeed, Elodie. So let's set the scene. What most customers and prospects are telling us today is that as BSS owners and or operators, they are concentrating on two core and somewhat conflicting challenges. That is to say, they need to ensure the safety and the performance of complex assets while delivering expected returns. By way of an example, we know that safety is a key and important part of BSS design. They are specifically built to protect battery systems from over temperature, over under voltage situations. But ensuring shutdowns from these safety mechanisms will affect availability rates, and we know availability rates are directly linked to profitability. Safety is paramount, of course, but these situations will inevitably affect profitability. So resolving this challenge is really important. This is where battery analytics solutions like PowerUp's Battery Insight come into play. By identifying and solving anomalies earlier through proactive maintenance, this will really effectively help the asset manager to buy time, resolve issues, and consequently protect revenues by, as an example, predicting or identifying anomaly precursors and solving them before they become a true safety incident, as an example. So this is where we start. And how does it work? Quickly explaining the big picture. The real power of cloud-based solutions is that they actually enhance existing BMS capabilities to track and resolve BSS anomalies. A battery analytics platform is a software stack that sits on top of the BMS and complements its capabilities with additional accuracy and increased depth for anomaly detection. This is what we will showcase in the next few slides with real use cases showing typical anomalies affecting assets of varying sizes and specifications and services. And even with high-quality BSS solutions like Socomec solutions, analytics bring additional value and operational insights, as we will show in a few moments. Just one comment to make sure how we address those use cases is fully understood. In some of those cases, we have audited those systems after the fact, after they have been affected by anomalies. And so we demonstrated we could have spotted the anomalies earlier and helped solve them. But sometimes we will see those anomalies clearly on the graphs. And that's just something that makes it easier to understand the way we've explained the situations, right? Our mission today is really to avoid these issues with daily monitoring and proactive care. Is that okay, Elodie? Is that right?
That's fully right. Yeah, I agree with you. And as you said, the intention of this battery insight is really to bring additional value. And here at Socomec, we really believe that this is something that our customers need, because they need to increase their performance. They need to prevent safety events. These are concerns for everybody. So it's really becoming a must-have for BESS systems. So that's why we are really pleased to work together, I think. And so let's start with some examples, as you said. I will talk to you about four projects that we selected around our operational base of 450 projects worldwide, on which, in fact, we had used the PowerUp tool to see what happened on systems. And all of these examples will highlight, in fact, how PowerUp solution really captures anomalies that the BMS couldn't detect or couldn't solve. So let's start with the first one, which is a typical site in Sweden, an installation of 1.1 megawatt hours, where we will see that cell imbalance really affects the availability capacity of a battery rack. So just to start a bit back, let's go back to why it's important that a battery has all its cells balanced. So in fact, if it's not the case, it will not be fully operational, because you will have some impacts such as loss of capacity that might reduce the usage of the battery, meaning also the money you can earn with your batteries. You might have an early aging of the battery, so then you will require more maintenance, thus more maintenance costs. And of course, this will also lead to some safety risks, as an excess of charge or discharge of a cell could really lead to an overheating of the cell. So what you can see on the graph on the left are, in fact, 3 lines that each of them represent one of the battery rack of the system. And as you can see, one of them, the green one, is fully disaligned with the others. So what does that mean? That means that you have 2 racks that have a state of health relatively high, and the third one is 8% below the others. So meaning that there is a clear underperformance with this rack. And not only has the tool of PowerUp been able to detect this difference of performance, but they could also explain why it happened. And in fact, in this case, the result is that it comes from a cell issue during the manufacturing phase. So the important thing to keep in mind there is that if we would have used the tool directly at commissioning, we would have detected the fault directly, and we could have replaced the battery from the start of the system, making it being used at full capacity as the capacity that the owner really wanted for its system, which was not the case. So, Philip, I think that you also observed such anomalies on bigger scale, no?
Yeah, absolutely, Elodie, and that's a great example. And indeed, not only do we see it in distributed energy systems, but also in utility scale systems like this one, a very large utility scale system of 600 megawatt hours capacity in Latin America. Same cell imbalance root cause, and even going deeper into what really is causing that problem, it could be different reasons. It could be SOC dispersion, state of charge dispersion, capacity dispersion, resistance dispersion. Each diagnosis leads to a different maintenance action. So it's really important to detect cell imbalance, but also to be able to go straight into the very precise diagnosis to know if the problem is recoverable, and if so, to recover part of or all of the affected capacity. In this relatively striking case, SOC, so state of charge dispersion, was the root cause. And clearly, the BMS balancing system failed to correct the issue and even made it worse. And that led to a huge 30% capacity locked due to the cell imbalance phenomenon. And this could have been prevented with proper analytics alerts. As we can see, those alerts started very early in time, as you can see on the graph with the orange bar showing daily alerts during a very long period. This capacity loss was eventually recoverable through active balancing mechanisms and BMS misconfiguration troubleshooting. But of course, this is what analytics brings to the table. The BMS is generally blind with those problems, especially with LFP chemistry. And even further, being able to identify the right maintenance action is something that only battery analytics can provide. So as we can see, small systems, larger systems, this problem is very often a problem that our customers and prospects are raising as being extremely important and affecting many assets transversally. Hey, Elodie, let's move to another case, the second use case of our list.
Yeah, so after cell imbalance, let's talk about SOC deviation. So, in fact, the accuracy of the state of charge is also an important matter for users, because for sure they want to make the most of their systems. And if the SOC is not the right one, they will not use the system as much as they could. Today, in a BESS, the SOC is calculated by the BMS, so the battery management system, from measures of voltage, current, and temperature. And this value is the value that the EMS is going to use in order to give the right control strategies to maximize revenues. So if the values that the EMS is receiving is bad, the EMS response will be bad too, or worse, let's say, that what it could be normally. So it's easy to understand that it can lead really to a disappointment of the BESS owner because the performance that he wanted to achieve might not be reached. And in addition to this, it can also lead to a damage of the cell. So one of the functions that PowerUp is providing today is the computing of a SOC value. So that means that they can also give us a value of the SOC. So on these examples in the Netherlands, we see in orange the value of the SOC given by the BMS, and in green the value that comes from PowerUp. And the difference between both can be sometimes more than 10%. Clearly, what does that mean for the user? In this case, the BESS is used by a customer that is having its systems co-located with EV chargers. So if the SOC value given by the BMS is higher than the real SOC, what can happen is that the EMS might say, it's okay, you can still do a fast charging there. But finally, if you don't have any energy available anymore, the charger will have to use the energy from the grid. And maybe it's not the same power anymore. And maybe then he will not do a fast charging. So for the user of the car, instead of waiting 20 minutes to get his car recharged, he might be there for 1 hour. So really not happy. On the opposite, if the SOC value is estimated to be lower, what the system might say is, no, you cannot use it anymore. And so maybe the owner of the charging station will just lose a charge, so lose money due to that. But the good news is that thanks to the battery analytics, it can really be detected and corrected by BMS recalibration. Isn't it, Philippe?
You're absolutely right, Elodie. And this problem of SOC deviation within a rack is also something that we see across larger systems. As we can see in this 50 megawatt hour asset in the UK, the difference between what the BMS is measuring and what the battery analytics solution is measuring is even higher in this example than it is in the previous one, with differences going up to 15 or 16 points, which is, of course, a very large number. And we've seen even higher numbers in other cases, like 20, 25%. So this drift versus or towards the true metric can also lead to important optimization issues, because of course the trader doesn't know how much energy is there in the tank when it has to take a decision, and so it's essential that this should be resolved effectively to optimize revenue generation. Coming back to the first slide, where you really want to protect revenues and profitability. So small sites, big sites, you want your state of charge to be absolutely accurate as possible. And there again, battery analytics provides root causes or ways to improve the SOC accuracy, recalibrating the BMS or understanding what is the cause of such BMS inaccuracies in the first place, and getting back to nominal expected measurement capabilities. So yeah, that is for a problem of SOC inside a rack. But Elodie, isn't there another anomaly that sometimes affects the SOC calculation when the state of charge deviates not only within a rack, but also between racks for no reason?
Yeah, exactly. So the intra-rack SOC dispersion is also an issue, and we have seen some of these. So as you said, before we had one rack and the SOC was wrong. Here, in fact, we have one system one PCS, so one conversion device. And on this converter, we have 3 battery racks that are connected. So all of them are using are powered with the same current. We apply the same current on all of them. All of them have one BMS, so one BMS per rack, but the 3 BMS give different values. So that's what you can see with the 3 lines here. And these values tend to diverge more and more because they are not detected immediately by the BMS because it's a slow divergence. It's not as if it's just a peak. So it's really something slow. So it's not detected. And in this situation, the point is that so each rack has its own value, and then you have a master somewhere that has to take all those values and give orders. And he's kind of lost because, okay, what is correct? What is wrong? What should I take as the real value? And this can really result in the worst situation in shutdowns of the system. What is interesting to see is that on this situation here in Sweden, if we had used the battery insight tool, we could have detected the fault, as you can see in the red circles. So really, the tool is able to detect a small divergence and then to solve also the issue, which is the most important point, is that it's possible then not to go to the shutdown, but really to say, okay, here there is an issue. Here we need to recalibrate the BMS, so to start again on our good value. Because if we don't do it, it will diverge, and there will be the issue. So that's really an interesting point that we can do that.
Absolutely, Elodie. And I think the impact in such a case where you have all the racks potentially connected to the same PCS, leading to a shutdown, that the impact is much larger, right? It can be a large number of racks connected to a single PCS, and if all of those are affected, then of course the energy affected is much larger than we are looking at the same phenomenon within a rack. Here we're talking tens of racks, potentially all affected by one that is, placing all the others at a lower capacity figure. And here in this example, with a larger assets in the UK, it's almost a perfect storm, right? The state of charge recalibration took place, all the numbers converged into one single value, and then just afterwards, all the racks, all the master BMSs indicated a diverging number in terms of what the state of charge is in the system. This is a common issue, especially when the depth of discharge of systems is relatively low. Typically systems that are supporting frequency regulation services, because they don't recalibrate themselves that easily by hitting low SOC or high SOC ranges. And so the divergence becomes larger and larger over time. So it's striking to see those similar phenomena in smaller or larger systems. And it's sometimes even hard to figure out if the BMS is the problem, or if there's a real difference between the racks showing different state of charge figures because of another root cause potentially. So analytics really helps owners, operators, asset managers to understand and resolve those situations early in time with the correct analysis and as early detection as possible. So last but not least, moving a little bit aside from batteries this time into thermal management. Isn't that also something that is a painful issue, Elodie, in some cases?
Yes, indeed. It can be a painful issue. You're fully right. And why is it? It's because batteries are quite sensitive to temperature. So it's really important to maintain them in a specific range for them to reach the best operation as possible, the best performance as possible. In fact, if the temperatures, varies too much, then this can result in an over degradation. So in case of high temperature, there can be a risk of fire, low temperature, really loss of performance, and safety issues. And the point is that the BMS doesn't really detect the thermal anomalies, or not early enough. So I'm going to show it to you right now. So on this graph, you can see there were 2 peaks of temperature. But these 2 peaks weren't seen by the BMS because, in fact, they weren't high enough to reach the threshold level of the BMS. So the good point is that there was no shutdown of the system. That's okay. But still, the temperature went quite high, which in fact is affecting the battery racks for days, maybe weeks. And the battery is suffering from it. It's getting weakened, let's say, and it will not last for as long as it should. And so here it's interesting to have also a battery analytics like Battery Insight, because the electrothermal model and the machine learning is really able to see and to detect the rise in temperature as soon as it occurs. And so we can correct if possible. So in this situation, the point was that there was an issue with filters. So it's an issue that can be quite easily corrected. So if you see it directly, you replace, and there is no long-term degradation on the battery. Whereas if you wait, it gets worse and worse, and finally you degrade the battery and you have a shutdown. So really bad situation in that case.
Yeah, that's a great case, Elodie, and I think we see it a lot in assets, and not only do we see it ourselves, but in a recent solar assessment report by Kilowatt Hour Analytics, I'm sure some in the audience have read that. There is a striking statistics from Clean Energy Associates indicating that thermal management system failures were found in 15% of their audited BSS units. 15%. So that's a pretty large number, and those events will affect batteries, will generate accelerated aging, and also potentially create shutdowns and affect availability rates. Coming back to the profitability topic we had in the beginning, that's something that everyone wants to try and avoid. So 15% is a pretty large figure, and so thermal management system failures need to be considered, whatever the HVAC systems technology or brand. And that's the magic into the feature that we're presenting here. PowerUp's detection mechanism only relies on battery data, not at all on the HVAC system data. And so this simplifies the anomaly detection greatly, and potentially avoiding the shutdowns that we want to avoid here, like this one that you see on a battery asset in Spain. So here what you can see is that the temperature has risen brutally, and this has generated a malfunction alarm. So the orange bar that you can see just below in the very first days after the start of this anomaly. And then even afterwards, this has generated a critical alarm in red, almost a week before the shutdown actually happens for a 10-day period. So this means that the alerting mechanism from PowerUp can actually give almost 2 weeks of reaction time, additional reaction time, to avoid maintenance to happen in an urgent manner, which is usually more costly, localizing the problem, understanding at the very initial time when it starts that something doesn't work and needs to be taken care of. this is not a thresholds-based system. It's, as you mentioned, Elodie, it's a system, it's a feature that creates, through machine learning, an electrothermal model of the battery after roughly 2 weeks of learning. And after that, it's able to predict the right temperature depending on the set points, and detect anomalies when the temperature differs from the prediction. And so it's not thresholds-based, it's independent from external data. It only relies on the same battery data that we use for other features, and it gives a lot of time to act whenever those problems occur. That's a real revolution, and I think it's really important to tackle those 15% problems that we see in the field, and that is a real problem from a performance and safety perspectives. All right, so those were the 4 use cases that we wanted to present today. We extracted them from many more, and of course we had to make a selection because we wanted this to be explainable in a 1-hour time frame. And still, of course, as mentioned by Andy, we can continue the discussion later and explain more on the context and on how the features have tackled those problems. But let's see how then eventually all this combines in a offering between PowerUp and Socomec that we will talk about now. Elodie, do you want to take that?
Yeah, thank you. Yes, so as you saw, there are lots of situations that can happen and that can be prevented. And that's what we want to focus on really this prevention, because everybody is annoyed if the situation occurs, if your system is shut, if everything is broken, you have to replace, it takes much more time. And that's really painful, because that means loss for you. And in the worst situation, it can also mean a really safety issue, which can be dangerous sometimes. So this is the reason why we wanted to integrate this analytics into our systems. So starting in Q1 2026, all the systems that we will sell, all the BESS systems that we'll sell, will be equipped with embedded analytics. And we will have different possible options depending on what are the needs and the knowledge of the people using it. So we can start with just monitoring and KPIs. This is mainly to give figures, and for people that are already that know already about it and that know what to do with these figures. For those who have less experience, we propose also a report with some advices that are really detailed and customized to your applications, to your system. And the idea there is, as soon as we see something, we can say maybe you could use more your system to benefit more of it. You could change something because as of now it's aging a bit too much, and so on. And later on, in a later date, we will also want to propose the 24/7 services, meaning that our team take care of everything. We monitor, we maintain, and we react as soon as we can. So as soon as the anomaly is there. That's really the idea to give our users really peace of mind with these systems.
Yeah, thank you, Elodie. And I think really we're all excited here at PowerUp to see this partnership continue, bring value and take shape. So this is an exciting moment where we are having this combined offer taking even more shape than before, with the 3 pillars that you just described. And so we are absolutely prepared to deliver those services across the world in all the regions in which you're selling your systems already today. So with that, we really hope that these use cases have been useful. We are at PowerUp spending a lot of time categorizing those anomalies, going deep into identifying the different cases with lots of precision, and we showcase the importance of implementing our battery analytics technology for improved safety and performance of your battery assets, whatever the sizes, whatever their shapes. And before we start the Q&A, we wanted to leave time for the Q&A because it's important to have that interaction. Just want to touch on 2 additional points. One is you can find our contact details here on this page. In case you would like to contact us directly and prolong the conversation, we will get all your questions, but of course, even easier to contact us by email if that's either today or at a later stage. And also, so we have published as well a comprehensive white paper. Maybe you see a pop-up helping you to access the white paper. Otherwise, you can flash the QR code. And this white paper illustrates even further with live data. Oh, here comes the the pop-up. Yeah, so this white paper is really comprehensive and goes into lots of details on plenty of other use cases, but focuses on one very important point, which is the financial impact of battery anomalies. We explain in this document how analytics can recover 10% or more of annual revenues that would otherwise be lost to those anomalies. So that's an interesting study. I think it's never been so detailed, going into a technico-economic study of how technical problems do translate into loss of revenues. So would be really interested to get your feedback. So, and I hope you will find that interesting. So please, come back to us if you have any questions on this or other parts that we have raised today. And I would like to thank you for your time and interest today, and we can start the Q&A session. So back to you, Andy.
Excellent. Thank you very much, Philippe. Yeah, so hope everyone was able to get the white paper download link. I'll admit I haven't yet read those white papers, but from your discussion of them, Philippe, and what you've been saying, I think I probably need to very soon, or I will definitely be missing out. So you can still get that from the QR code on the screen, or you can go to PowerUp's website as well. So quite a few really good questions coming in. You do have a few more minutes while we're doing these to ask more questions. So feel free to do that if you're in the audience and you have something you'd like to ask Philippe or Elodie, or both of them, I guess. That said as well, it's worth putting in your question if you really want an answer, even if we're not able to do it live in the broadcast, because we don't have that long to do the questions now. Fair chance you'll get it answered, but possibly not. But if not, you will be able to speak with PowerUp and Socomec in more detail. So I'm not sure how to do these. We've got a couple that were specific to things that were shown in the presentation. So we'll put those on hold for the time being. But I think we had a few questions about the overall, I guess, just how data analytics works, really. I was going to say about the value proposition, but it might actually be a more basic level than that. So Ricardo, thank you very much for your question. Ricardo asks, do you monitor in real time the data from each cell in the system? So Philippe, I don't know if you want to give an explanation on how that the data monitoring works from cell level, and any color and clarity you want to add on that.
Yeah, that's a great question. I think it helps position battery analytics versus other systems which are using real-time BMS data as an input to provide immediate reaction. What battery analytics provide is not real-time by definition. It's near real-time because we're using BMS data as an input, but we are recomputing all the indicators, the famous state of health, state of charge, remaining useful lifetime, cell imbalance characterization, that require a little bit of time for our algorithms to provide their results. So that's why it's not real time. It's near real time. It requires, few minutes, sometimes a few hours to generate and refresh a result. But it goes much more in depth and it provides additional accuracy than what the BMS could provide immediately. So that's why battery analytics are a little bit different than systems that are simply taking the BMS data without challenging them. And so that's what makes the difference between completely real-time systems and battery analytics systems. And I think, thanks for the question again, because I think it helps, segmenting and explaining what we do and what we don't do.
Yeah, I mean, Elodie, is there something to add on that from the user perspective, in terms of what that sort of looks like from your point of view, and how information from the systems is fed into, let's say, insights that you can take action on?
Okay. So generally, first thing is that we were talking about real time, and to take actions. In fact, I'm not sure that real time is really necessary, because even today our systems monitoring is not a real time refreshing of the monitoring. But for sure, we know that we have some data at module level, some data at track level. So it's really interesting to have both level of information, because that gives a real insight into the battery, and it really helps to find out the solution. So I mean, from what we have seen, when we did all the tests with the all the tests we did with PowerUp tool, it's really helping to get a, let's faster, I don't know, but yeah, faster analysis of the situation and faster understanding of the root cause. Because sometimes before we just replaced some parts without knowing, in fact, why we place them. It's a bit like at home when you lose electricity, you go and you turn it on again, but you don't know why, and then it breaks again just after. So the idea is that we want to understand why, and due to this analysis of the data, we really get to understand why.
Yeah, that's a great analogy, I think, Elodie, and especially for anyone like me who's tried to run air conditioning, an air fryer, and a kettle, and a toaster all at the same time, only for all the electricity in the apartment to go off. So I shouldn't joke about it really, but no, that's a great way of looking at it, I think. And so there's a question here, maybe a little bit of a philosophical question on the value of data analytics. I don't know how you want to handle this one, but so thanks for your question, Alberto. Alberto says that many battery manufacturers are updating their firmware with improvements in the state of charge recalculation estimation. A bit more of a statement than a question there, Alberto, but I guess what Alberto is getting at is that the battery manufacturers are providing or trying to provide more granularity into what's happening, and more visibility, I guess, into what's happening with their batteries, I guess, including things like state of charge recalculation. So I don't know if you want to flip this the other way around and Elodie go first and then Philippe, I'm not sure, but why would you not just rely on what the battery manufacturers can give you if that is improving? And, where's that value really, I guess, in analytics?
So for sure they're working on it, and for sure if they improve the performance, it's really good, and we will not say it's useless, of course not. What we see today is that there is still some deviations, and the important topic also is that, I mean, today we ask our customer to do some recalibration at fixed periodicity, and this is something that's the pain point. So we could ask them to do recalibration every week, maybe that would be the solution. But then if you do that, it's sometimes complicated, because it takes time to do. You don't have the load to do it. So really, to have a system that tells you, I see there is a deviation, I see there is a need for this recalibration is really helpful. So as of today, I would say that if the battery gets better, that's a good thing. But why not keeping the two systems running in parallel? And if finally they get to the same, that's just a double safety check, in fact.
Yeah, that's very true, Elodie. And I would just add to it that this problem has been getting worse with the emergence of LFP chemistry. I think we all know that there is a specific technical characteristics of the LFP chemistry, that the OCV curve is very flat, and so there is a difficulty for a BMS at a certain voltage levels to understand what the state of charge is for an LFP battery, and this makes it hard for a BMS system, which is eventually a local system with a small computing power and limited capabilities in terms of working out those problems, not to fail sometimes, and not to be incapable of providing the right accuracy. What battery analytics provide on top is the almost unlimited computing power of the cloud, enabling complex algorithms to work out and provide this additional accuracy and additional value at the expense of near real-time capabilities. So that's where the two worlds get together and complement themselves. And I think I'm still here to wait until a BMS gets perfectly able to measure the state of charge of an LFP battery. Things are getting better, but at the end of the day, I think the power of the cloud will complement the local capabilities of a BMS, and this is going to last for some time, I believe.
Does it also help, I guess, to have a layer of a sort of third-party verification then of system performance and health? What I've heard anecdotally is that this can have bearing on things like system warranties, or when it comes to bankability and financing for projects and things like that.
No, it's a good point. It helps, as you said, also monetize the battery asset. State of charge indicator is a critical one for optimizers to capture high price when it happens in the markets, to make sure that the state of charge is not wrong by the 10, 15, 20% we talked about, and miss an opportunity. So this is important for the entire chain of from the asset manager to the optimizer, to make sure that the state of charge is correct, and having a third-party battery analytics provider to help in that process is, of course, I think an interesting thing to add to the value chain.
You are talking about warranties now, weren't you, Andy, if I
Mm-hmm.
understood well? So if I may just add, in fact, what we can see is that sometimes to have a third party doesn't really always work for the warranty. I mean, we need to convince the battery manufacturer that the value coming from this analytics are correct, and that they should take it as value to should accept them, in fact, and not ask us to review, test, and all that. So that's a point, but that's negotiation part, I would say. But what is important, though, is that in terms of financiers, when our customers are looking for financiers to buy the systems, it's important to show to them that something is in place to really enable the most safety of the system and the best performance. So here, this third party makes really, really sense to those customers here.
Okay, that's really interesting. Yeah, thanks very much. It always seems the way that you always have to think about the technical benefits and then the business benefits, and yeah, it's always interesting where those things sort of overlap. So, on a somewhat related note, got a question here from Oscar. And Philippe, you did mention the sort of interaction between the well, essentially between whoever's trading the battery in the market and whoever's kind of, you know, operating and maintaining the battery, I guess, where the analytics has a more direct role. But so we had a couple of questions, in fact, about the interaction of analytics with other layers of software. And so the first one was about kind of route to market optimization and trading, and the other one's on cybersecurity. So we'll take Oscar's question on trading and optimization first. So thanks for your question, Oscar. Oscar's asking how is this combined with algorithmic trading services? So are the analytics used instead or before the more trade-focused BMS takes over? So I'm not sure if all the terminology kind of is as I would understand it, I guess, but I think it is maybe a broader question, Philippe, on the interaction between what the analytics does and what a route to market optimizer might do, I guess, and yeah, where they play a role in that trade-off.
Yeah, no, that's a great question, and once again, I think we are not replacing the BMS with battery analytics. We are assisting and supplementing the BMS with additional insights which come in a near real-time manner. So whereas the optimizer will have to rely on the BMS measures for real-time decision making, and as such, the optimizer or the route to market provider is interested in us battery analytics helping asset managers unlock tradable capacity, as an example. When we've seen in the first use case of this presentation that sometimes, you know, up to 8 to 30 points of capacity were locked in some racks due to sell imbalance. This locked capacity is a capacity that the trader cannot use to trade on the markets. And so if we are solving that problem technically with asset managers, unlocking the capacity, then the route to market provider will have many more megawatt hours to trade with. And that's in itself an enhancement for his service. So that's how we work, really. We work to improve the relationship in between optimizers and asset managers to make sure that the assets are optimized in terms of capacity, in terms of availability, so that, for instance, the system is up and running at the right time when the markets are high. And all of this contributes to a better performance. And so we are not, again, trying to replace the BMS in real time. We're trying to improve the performance of those assets by taking the right measures, by improving proactive maintenance and making sure that traders can act whenever they need to act with, you know, the biggest available capacity possible.
Sure. And Elodie, is there anything you could add from the Socomec perspective on that?
Honestly, it's quite difficult to add something. I think Philippe had a so complete answer that I don't know what to add. But I fully agree with what he said, in fact.
Okay. Well, maybe if you answer next on the next question, then you can get in before
Okay.
him. And yeah. We'll see. Although, yeah, I'm not sure. Well, we'll see what you think. So Andy, great name, Andy, asks, how do you manage and/or mitigate potential cybersecurity threats between remote sites and the central hub where data is evaluated and decisions made? So again, like the interaction with other parts of software, you know, I think we don't think about it that much in terms of energy security and cybersecurity at the moment. I know a lot of people do, particularly at, you know, government level and various, and perhaps, you know, more of us should take it more seriously. But yeah, any views on that, Elodie? And I guess just in terms of making sure everything on site is and off site is really, you know, tightly managed.
I will let Philippe answer on how he does it, but what I can say is that for sure cybersecurity is really essential for us. We are looking at it not only with this tool, but as standard, in fact, all of our systems are connected. So that means that we need to have access remotely on our systems in order to operate if there is a software update, or if there is an issue or something, or to just get the alarms, to get the battery data and all that. So as soon as we have a system on the field, it is connected. So for sure, this cybersecurity thing is important for us, and we are working on cybersecurity certifications at Socomec at the moment. So should you have more question on that, the documents are available, so we can give you more info later on. No problem.
Yeah, just to add on what you said, Elodie, I think, well, cybersecurity is paramount for us to ensure that to our customers. We do not add any sensors or systems on site, so we are preserving the security of those remote sites. As Elodie said, most of the time, the data is already flowing to central data lakes that customers have available for their own maintenance capabilities. And what we are doing is we are basically collecting the data from those central data lakes or central folders, collecting the data with safe measures, safe, secured FTP systems or APIs that are also extremely secured, and then working out those the data within our cloud provider infrastructure, which is also cybersecurity, I would say, preserved, and with lots and lots of procedures to ensure that. So with that, we're delivering back to our customers operational and insightful KPIs through the web, but let's say their data is completely preserved. And throughout all the chain, we are ensuring cybersecurity measures to make sure that, first of all, their data is very well protected, and secondly, that we are not impacting their sites at all. We are not actively modifying anything on their sites. We're just providing information, operational insights that they can use afterward to launch active measures. But that would be a second step. So with that, we are providing analytics and not messing up with anyone's data or anyone's sites whatsoever.
Excellent. Thanks very much. And we're pretty much out of time, folks. But should we just do one more quick question, and we'll finish it up there? I think. So we had a couple of questions on this, but I guess. Yeah. So David asked. Thanks very much for your question, David. After all the data anomaly detection is organized, how do you teach or calibrate the system to adjust your expectation of performance envelope in the future? So how do you input or assign correlation or cause along the timestamp matched data? Now, to be fair, some of that goes a little bit over my head in terms of my understanding of these technical topics, but I guess, Philippe, this is about how you optimize that performance through the lifetime of the asset. And so you will have, I guess, initial fault detection and stuff, but then after, a while of operating it and certain revenues and what have you, you will have expectations of how the system should be operating and should be optimized for, maximum revenues versus best battery health. So, David, I hope I've interpreted your question somewhat correctly, and this is going to be somewhat useful for you. Does that make sense to you, Philippe? And what's your view, if so?
Oh, it makes a lot of sense. I could spend 15 minutes or 20 minutes answering. It's a very wide question, and I think we don't have that time, unfortunately. But so I'll just say two things. One is that correlation between different anomalies is a key development area for us at PowerUp, because we believe that correlation mechanisms can make life easier to asset managers to understand, instead of having 10 alarms, just having one that aggregates all together and gets to the root cause of the problem in a single and powerful manner. So correlation capabilities, we will add in our system more and more, because we really believe that makes a lot of sense in the frame of what we are doing in terms of battery analytics being so complex systems, encompassing many different things together and getting to what counts, what is the priority to act on a, let's say, a large array of alarms. First, quick answer, could develop further if needed later. And second is, yes, we do translate that into lifetime impacts potentially. And this is critical at times where, batteries are impacted by high temperature. We saw that a few times in use case number 4, or other anomalies or usage parameters not being completely adequate. And this translates into potentially years of life expectations missing in the business case. And so, again, I could dwell on that for a long time, but I think, long story short, we are indeed at all times being able to provide the remaining useful lifetime, as we call it, which is a calculation taking into account the battery model and the real usage, and then providing optimization capabilities to enlarge the lifetime, to make, to add a few years and avoid augmentations whenever possible. So very interesting question. I would love to, continue that with a person later, but I think we're 7 minutes over, so I'll stop here.
Could be a webinar topic in its own right, couldn't it? I think. But yeah, I do want to give you the opportunity, Elodie, if you do have any views on that. So from Socomec's point of view, it's been, I guess, a couple of years for the longer sites in operation using the PowerUp analytics. How do you sort of foresee the role that analytics will play, in future years once the system's been operating for a while, and you have an understanding of what both the system can do and what the analytics can do?
Yeah. So what I see in the future. So at the moment, we are only implementing battery analytics. So that means that we really focus on batteries, because in fact, in terms of safety, that's the main points. But to improve the real performance of the system, what we want to reach finally is to reach a full system analytics. So meaning that we want also to monitor the converters and the other elements as much as the batteries, because all of them work together. So I mean, sometimes there is an issue on the battery, but that can have an impact on the converter and vice versa. So the idea is to tackle all of this as one asset together, and to make still improve the performances thanks to this. And I think Philippe and his team will be happy to work with us on such topics.
Yeah, certainly. I mean, it's already been, a fascinating story how the analytics space has evolved so quickly, and certainly, yeah, we look forward to seeing more on that, and I'm sure many of our readers do as well. So that concludes today's webinar. I really want to thank Philippe de la Fortelle and Elodie Heston for taking part as speakers. Thank you so much to both you and to your organizations, PowerUp and Socomec. But the biggest thanks of all, of course, goes to you, our audience. Thank you so much for signing up. So many of you taking time out of your day to spend it with us, and I hope you've enjoyed it as much as we have. And we'd just like to say as well, thank you so much for being part of this vibrant and exciting industry that really is changing the world from one cell to a system at a time. So yeah, thanks very much, and we look forward to seeing you next time around. All the best, everybody.